Hey guys, I got a request asking me how to do a few homework problems from Chapter 8, Lesson 1. So I'm going to do a few homework problems from page 537. And so if you had any questions over these problems, I'm doing 19, 21, 23, and 25. So going over how to find the altitude and the legs and other parts using the geometric mean, leg theorem, and altitude theorem. So let's take a look at 19 here. The first thing we want to do when we're working through our problem is identify what information we're given and what we have to find. So right here, we're actually given the altitude, which is a good thing. And then we are just missing this part of the hypotenuse before we can, fill out all the blanks of the altitude theorem. So if we think about the altitude theorem, the altitude equals the square root of the two parts of the hypotenuse, right? So if looking at it like this makes more sense to you, then you can write that down for sure. So I know the altitude is 17. I'm going to plug in 17. That is the square root of 6 times this other part of the hypotenuse. So 6 times, let's just give it a variable. X, Y, and Z is taken, so I'm going to say A, okay? Now, when we are trying to work backwards and we've got a square root, we can just square to cancel it out. So if we square here, the square root cancels out with the square. However, if we square on one side, we have to do it on the other side. So 17 squared is like 289, I believe. And then you have no square root. You just have 6 times 8 because the square root is gone. So 6 times 8. Now to get A by itself, you would just divide by 6. And then you are left with, let me plug it in on my calculator. $48.16. 166, so 17, maybe 48.717. So now, if you wanted to find y, couldn't you just add that to add what you have in A to 6, which is the other part? And so y equals 48.17 plus 6. And when I add them together, I get 54.16, or I'm going to round it to 2. I could round it to 0.2 if I wanted to, or 17. So that's your answer for y. Now we found y. That's good. Let's do x or z. Now, x and z are the legs, so we're going to use the leg theorem. And the leg theorem states that the leg is the square root or the geometric mean of the hypotenuse and the part touching the hypotenuse. The part of the hypotenuse that's touching the leg, right? That's a lot to write out for me here. So I'm going to just ... there, okay? So that means x equals the entire hypotenuse, which is y, and we actually found that. So that would be 54.2-ish, right? We're rounding, or 54.17, times the part of the hypotenuse that's touching the leg. So we're looking for x. 6 is touching x, and so we're going to multiply that by 6. So go ahead and plug that in your calculator. 54.2 times 6, and then square root that. and that is about 18.03. Okay, and that's x there. All right, to find z, z would be the square root of the entire hypotenuse, 54.2, times the part of the hypotenuse touching z. So that's this segment right here. We don't have it labeled for us, but we did find it. That's actually, we gave it a variable and it's a. And so we could just use that in place and say 48.17. And so we're going to multiply that out and square root it. So 54.2 times 48.17, it's like 2,000 something. We're going to square root that, and z equals 51.09-ish, or 51.1. So if you want to round your final answer, my suggestion for you is when you're working the problems out, round it to the nearest hundredth, and then when you write your final answer, round it to nearest tenth. So this would just be 18.0. This would be 51.1, 54.2 here, and then 48.2. That's good enough. Okay, so that's how you do 19. Let's take a look at 21. I think I'm going to do 21 with you and then leave you hanging with 23 and see if you can figure it out using the examples I did up here. Okay, so 21. Let's take a look at what information we have. We have the entire hypotenuse and we have one of the legs, okay? We don't have the altitude and we don't have either part of the altitude. And so if I were to use my altitude theorem first to solve, I would be stuck because I've got more than just one unknown. So let me use this leg to kind of go off of, okay? I know that the leg is the geometric mean of the entire hypotenuse times the part of the hypotenuse touching the leg. So the entire hypotenuse is 14, the part touching the leg is y. So I'm going to work backwards by squaring both sides to get rid of my square root. 5 squared is 25. Now I'm just left with 14 times y. So to get rid of 14, divide by both sides. And then your answer, it's like 1.79. So it's a really, that picture is really not drawn to scale, right? 1.79 is y. All right, so now we can use what we have to help us find other parts. If this part is 1.79, and it is true, the drawing's not great, it's not very, the scale's not very accurate, but if this part's 1.79, what would the rest of the hypotenuse be? So we just have to subtract. 14 minus 1.79 equals 12.21. So this part here is 12.21, and I could find z. So z equals square root of 14 times 12.21. So I'm going to multiply that and then square root. It is about 13.07. Z equals 13.07. Now I need to find x. Well, the nice thing is I have the two parts already. So x would just be the geometric mean of the two parts of the hypotenuse. 1.79 times 12.21, square root, multiply and square root. And x is about 4.67. And that's your answer. I know that when you check your answers, the book gives your answer as simplified square roots. And so you have to plug that in, find it as a decimal to check to see if you got it right. Okay, I'm going to leave you hanging on number 23. It's similar. You've been given different parts of this information, and I think I would suggest that you start with using this leg to find z first. So that would be step 1. Okay, our final problem. So number 25, there's a graphic drawn for you. It says Michaela is using a book to cite the top of a waterfall. Her eye level is 5 feet from the ground, and she is a horizontal distance of 28 feet from the waterfall. Find the height of the waterfall to the nearest tenth of a foot. Okay, so this picture is a little bit tricky because it's like, well, are we looking for this part? Or are we looking for this entire part? So I'm going to jump the gun and just tell you we're going to find the entire length here, the entire hypotenuse. And so let's talk about what information we have. We have this segment, which is 5 feet. And if we're looking for the entire length, then which theorem would we have to use? I think we would have to use the leg theorem, right? Or, I mean, we could use the altitude theorem and then add the two parts together. So we could try that, right? If this is 28, then this altitude, if we just bring that up, will also be 28. So basically, we have 28 equals 5 times x to get this part here, this part of the hypotenuse. And so to get rid of my square root, I square both sides. 28 squared is 784. And then you have 5x, so divide that by 5, and you have 156.8. Okay, now that's just one part of it. So if we wanted to find the other part, we would just have to add 5 to that. So if I add 5, then I have the entire hypotenuse, because these two parts of the hypotenuse make the entire hypotenuse, right? So 156.8 plus 5, and the answer of the entire hypotenuse is 161.8 feet. Okay, there's another way you can do this, and that involves using the Pythagorean theorem, but I think this way is a little easier because you don't have to do things that you haven't done in class. So there you go, some homework problems that I kind of put up here. If you are still concerned about 23, come find me and we can talk about that.